So good morning, everyone. Till yesterday, you saw that only one person was giving the presentation. So last night I watched news and I thought, why not two anchors? So that's why we made this duo. So I'm Amit Kumar,
And I'm Suhail Ahmad Baba.
So he will start the presentation. I will come up after that.
Good morning everyone. Today we will be discussing about the mechanical properties of limestone calcined clay cements. So these are the contents that we are going to discuss today. We will start with the introduction and then we will move towards the definition and importance. Then we will be discussing about the contribution of cements and mechanical properties of concrete. Then we will discuss about how Lc3 behaves as compared to the traditional cements. Then we will move towards results in plain and reinforced concrete. Then we will have the summary at the end. So now starting with the introduction, what are the mechanical properties? So mechanical properties are the physical entities that a material exhibits upon the application of forces. So this essentially means whenever the structure or any structural member is subjected to any kind of loading, what will be its response, how it will deform, how it will bend. So for example, examples of the mechanical properties are modulus of elasticity, tensile strength, elongation, hardness and fatigue limit. So what happens when we know the mechanical properties of concrete? We are able to ensure the safety, the serviceability and the durability of our structures. Now, we will start with a little basics. What are the different types of forces or loads which are acting on a structure? For example, we have a dead load. That dead load is essentially the load of the structural components. For example, the wall, the floor. So our structure, it has to be strong enough to resist the compressive forces, which is itself the mechanical property. Then we have the live load. The live load is the load of the. It varies with the time. For example, the load of the people, the furniture, etc. So our structure or the structural member, it needs to be strong enough, yes, with the compressive loads and the flexural loads. Then we have the snow load here. This is the region specific load. The loading distribution is the same way as the live load. The structural member needs to be strong enough to bear the compressive loads there. Then we have the hydrostatic and soil pressure. The structural parts which are in contact with the soil, they need to be strong enough to resist these forces. So cutting the bigger picture into short, the safety and the reliability of the structures, we need two things, the material part and the design. But here we will be discussing about the material part only. Now let's deep a little bit deep into this. Why studying mechanical properties is important. So firstly, starting with the material selection. As we know, we have different types of constructions in practice, and different kinds of constructions need different kinds of materials and having the different kinds of mechanical properties. Knowing the properties, we can choose the best types of materials having for our intended use. Then we have the quality control. The mechanical testing of the materials, it allows the manufacturers to produce the materials of the standard quality. Then we have the optimization and improvement. As we know, the mechanical properties, they depend on a lot of factors. For example, the water cement ratio, the type of cements, etc. So playing around with those all parameters, the researchers can optimize and improve the mechanical behavior of the structures. Then we have a prediction of performance. If we know the mechanical behavior of the materials beforehand, then the designers and engineers can predict how it is going to perform in practice and under different loading conditions and under different environmental exposures. Then we have the durability at the end. Generally, we say the materials having the good mechanical properties, they will be durable as well. Now, these are the details of the studies which have been performed here at IIT Delhi. So the mechanical tests were conducted on plain concrete and reinforced concrete. And the compressive strength, the split tensile strength, the bond with reinforcement, flexural strength, modulus of elasticity, like these parameters were evaluated. This is the mixed design. 2 grades of concrete were studied with the water binder ratio of 0.5 for low grade and water binder ratio of 0.3 for the high grade. In this, the 3 cements were used for each tube: the OPC, the PPC, and Lc3. The control parameters that were used in the study are the water binder ratio and the superplasticized dosage. And the properties that were measured are the slump and the strength. So this is the compressive strength test. The compressive strength means the maximum amount of compressive stresses that a material can bear without the failure. It is the most useful mechanical property, as a lot of other properties indirectly we can derive from if we know the mechanical property, if we know the compressive strength of this using different types of equations. For this, the Indian standard 516 and 1959 was used. These are the results of the compressive strength. In this, if we will see this band here, this is the plus minus 15 band, which was used to check the comparison of these 3 cements for 7-day strength with water binder ratio of 0.5 and with water binder ratio of 0.45 at 28 days strength. The results are very comparative, and similarly for this case. Now, flexural strength test. This test is used to assess how the beams or any structure will bend upon the loading. It is very useful for assessing the performance in beams, slab pavements, precast drains, covers, etc. The test was conducted as per the Indian standard 5161959, and 4-point loading system was done just to to create the pure bending moment zones and not the shear forces. These are the results. Again, the Lc3, OPC, and PPC, the results are very comparative at 7 days and 28 days. Now, from this onward, Amit will carry on.
Thank you, Suhail. So, till now, what we saw was the perspective of a researcher, like what is the comparison of OPC, PPC, Lc3. But now I will move towards the perspective of practitioners. You give something to practitioner, they will see the results, but before the use, they will see how it is performing actually. So we tested the modulus of elasticity. This property is needed when you try to assess the constitutive property, like you have applied a force and you want to know the displacement. You have applied a displacement and now you want to know the response in terms of stress. So for that purpose, modulus of elasticity is very important. So we use the procedure mentioned in 516, where we load the structure in cycles, and then we measure the strain and stresses developed with those cycles, and we take the slope of the last loading cycle of stress and strain curve. These are the results. We find that all these cements perform similar. The modulus the elastic modulus is similar for all of them. Then we perform split tensile strength test with these cylinders, and this is very standard test. You can see in 5816. These are the results. Again, you can see the results are very comparative, and all the results are within the band only. Beyond this, we measure the interaction of concrete with steel. Till now, it was only concrete. So, how concrete is compatible? How much compatibility is with the reinforcement? For that, we measured the bond strength. We took 2 types of reinforcement bars, 12 mm bars and 25 mm bars. To have this, we prepared a sample like this, where a cube has a reinforcement embedded in it. To ensure that this reinforcement is perpendicular to this, we took what we say a spirit level. So this is a testing arrangement where we rested this cube like this, and we pulled this reinforcement bar down, and we measure the relative slip between the reinforcement and the concrete cube. And again, you see the results are very comparative. They are very similar for both the grades. Like we have prepared two type of blend, 0.45 and 0.30. So it is similar for both. Now beyond this, up to this, like only the individual performance. Now we move towards the actual performance of the structural elements. So for that, we tested beams and slabs. In beams, we measured the primary purpose. You know, the beam is designed for flexural stresses and shear stresses, and then we observed the displacement and crack patterns. And then we tested slabs also, which is designed for area load, flow load, and we measure the flexural, we measure the strength as well as we observe the displacement. So these are the two mixes we used. We kept the total binder content same. So this is the pointer. Yes. So this is the beam, and we keep on applying load here, and we measure how the cracks are developing, how the beam is deflecting with the help of these three LVDTs. We have installed two strain gauges in the bottom reinforcement bars, and we measure the strains as well. So this is an example of one of the beams that we tested there. Again, you see the all these results. They show very similar results here and here. This is the strain versus load, and this is central load versus central deflection. This is the peak load registered by the beams. You see the theoretical strength is much below that. I mean, we have achieved greater strength than the theoretical strength, and this is even when without the safety of factor of safety, which is 1.5. So it is much above that. So again, for the higher grade, similar results. Then I have to just skim through because all the results are just similar. Then we performed shear test on the beam. We just removed all the rings. We just keep two rings in the end to hold the bars in position. Again, two LVDT. The LVDT was installed in the center to measure the deflection, and then two strain gauges here. This is a example of a failed beam. You see a typical shear failure was observed, and these are the results. You see the peak load registered by them was all within this experimental area range. Again, similar results for the higher strength concrete. And then these were we carried out tests on slab. Since slabs are designed for area loads, but we have to apply it through this single point load. So we distributed this load into 16 point load so as to simulate flow load. And during that test, it was difficult to maintain the stability of this loading points because of the non-uniform deflections of the slab. And again, we see the peak deflection, the peak load registered by the slab was again similar. So the summary of saying is, if you design your concrete or your structural members with Lc3, it performs similar. You do not need new design codes for that. You can use the existing design philosophies, existing design codes, and you will have a similar performance in your structures. We are in process of studying more mechanical properties like fire resistance and pre-stressed concrete, and in few months we will be able to discuss on that as well. So thank you everyone for your time and patience.
Thank you.